Here, let's say definitely for you is like you saw how the idea progressed, right?
Yeah.
I think for you, what you need to do is try to not just understand the optimal solution, but try to understand what it takes to go from the naive to optimal solution as well.
Hello, can you hear me?
Yeah, yeah, I can hear you.
Yeah. Hi, how are you doing?
Hey, I'm doing good. I'm doing good. What's up?
Yep, things going well here.
hmm Yeah. So how'd you find out about me?
Um, I'm in a lead code practice group with two of my friends,
hmm
and I think one of them is in a boot camp with CodePath, I think,
hmm
and and somehow she referred me to your guide of practicing for the technical interviews, and that's how I found out about you. And I've been finding it super helpful in getting me into the right mindset for the interview. So thank you.
Yeah, for sure. So tell me a little bit about yourself. Where are you at the interview process? Where do you think you're messing up, and what are you trying to get out of this session today?
Sure. So my name is Anthony, and I am a rising junior. I'm looking for summer internships in 2021. And right now, I have been focusing on this summer. I've been doing a part-time internship while focusing most of my time on doing legal problems, and also working on one or two side projects in web development. In terms of lead code, I I've done about 65 questions so far, um, and most of them are in the medium range. And I have and I guess some of the topics that I definitely need to work on are like dynamic programming, graphs, and trees. So those are the things that I'm kind of like having a little bit of trouble. Um, and other than so, and I'm really interested in having more interviews, because it is definitely not the same when even though I'm practicing with my friends regularly, it doesn't really have the same feeling as if you're doing it with a complete stranger. Um, and I think having someone who really knows the process like you would definitely help.
I see. Okay, so it sounds like you're in the middle of it. So let me delve a little bit further into what you just said about dynamic programming, graphs, and trees. Is it something that you don't understand about them, or is it that you struggle with these types of questions more?
Um, so I guess mm, it's more like I guess I haven't done enough practice to be good at them, and I haven't been like I haven't like when I come up when I stumble against these questions, then it does take me a lot of time to figure out what to do.
I see. Okay. And how do you feel about like your arrays and linked lists?
Um, so for arrays, it's also kind of on and off. I think some questions I can sort of solve within like 35 or 40 minutes, but then others is still taking me a lot of time. Um, so I wouldn't be able to figure out what to do within like 10 or 15 minutes. So I guess mm, it's not too like there are some questions like if it's like sorting, then I can kind of see like yeah, I can kind of identify that these questions uh will use sorting in some sort of ways, but then I haven't known all the techniques to work with arrays yet. um I know pointers. I've done quite a bit of questions with two pointers and um, things, yeah, two pointers
I
and
see.
sorting. So those are the things that I'm more familiar. but other techniques, I haven't seen too many of them. And linked lists, I think I've done like reversing linked lists, merge linked lists together, and what else? Yep, I'm just gonna look to my LeetCode sheet real quick.
Go ahead.
So, this here. Um, yeah, and like kind of merge linked lists together, reverse linked lists. So those are some of the and merge to sorted lists. So those are some of the questions that I have done with linked lists so far.
Okay. So let me see if I understand you correctly. If your tendency is that if you don't really understand the problem with or really know what to do within the first 10 to 15 minutes, there is no way you're going to solve the problem. Is that right?
Um, yeah, actually, like before, like I used to practice in kind of like a different way. So I used to spend like a lot of time trying to figure out like maybe 30 or 60 minutes,
Mm-hmm.
even in an unknown questions. But then like right now I'm kind of shifting towards like if I can really see the pattern within 10 or 15 minutes, then um, like 15 or 20 minutes rather, then I would give up and see hints.
Okay. So here's my dilemma with what you just said is it sounds like you're kind of memorizing problems and then you're referring back to them in order to try and solve the next time. But you don't really do too much work to actually try and solve these problems. Is that accurate to say?
um, like I used to put in a lot of effort to solve the problems.
Mm-hmm.
Actually, like I would spend like 30 or 60 minutes even for the questions that are of the topics that I might not necessarily have seen before.
Mm-hmm.
But right now I feel like that have been taking me quite a lot of time, so I'm kind of shifting through towards like trying to solve it within like 20 minutes. And if that doesn't, and if I can't see anything, then I would skip on and look through the hints and the discussions, kind of see the idea and then see if I can code back the solution. Yeah. Does that make sense?
Yeah, that makes sense. The problem I'm having right now, looking at when I see this, when I hear that from you, it makes it sound like you're just memorizing solutions, so that way the next time you see something, you're not going to be able to know how to dissect the problem because for these coding interviews, you're going to run into problems that you absolutely have not seen before. You might not really know anything similar to them, and you're going to have to dissect and solve these problems. And what I'm afraid of when you're practicing like this is that you stop developing your ability to actually dissect these problems, and you rely a lot more on having seen the problems, which I think explains some of your inconsistencies with the data structures.
Hmm.
Because usually once you
Yeah.
understand the data structure, you can pretty much hit the and when I say understand it, I don't mean in a textbook sense where you can rattle off the definitions of them off the top of your head. What I mean by this is you can actually execute on those data structures and in a very comfortable way. And what I'm hearing from you is that you're not growing comfortable with being with executing on those data structures. Rather, you're just relying on memorizing solutions, and that's the big red flag I'm hearing from you right now. Is that sound right or wrong?
Mm. Um, so I think, yeah, I actually feel like I'm not really following like I'm not really reading up on the data structure and algorithms before solving problems.
Mm-hmm.
So I would kind of, yeah. So I think it's like what you said is yeah, it's mostly correct. Like I would try to still like struggle with the problems for 20 minutes, and if that doesn't work out, I look at hints, see the solution, try to code that up without seeing the solution. But I guess it doesn't. I don't really go through the process of thinking about why, like how I can dissect the problem, like you said. So yeah.
Yeah, so when most people come to me, it's almost never just for interview practice. It's also to dissect their thinking, and how to become more efficient and better at solving these problems. It's never just really a mock interview, if that makes sense. That's why that's why I'm pretty in pretty high demand right now, because I can usually get people for over a few hurdles within one session. Do you watch my YouTube channel?
Yeah, I think I saw one of your video when you interview with one like I think another person who's also looking for internships next summer.
Yeah. Okay. So you've seen that. So given that, so you're pretty familiar with the process. I'm going to record what you're doing, and then we're going to review and watch it. Based on what you just said, you don't really seem to be comfortable with trees. Um, I'm not going to ask you dynamic programming, but I was thinking, okay, you have one of two choices. We can go for a graph or tree problem, or we can try hitting your mechanical skill. Which one do you want to do?
Um, so I guess I kind of want to go to see like with the problems that I might have seen like I might yeah I think more like the mechanical skills like you mean like the ones that I have that I feel like I'm comfortable right now.
No, the mechanical skill are ones where it doesn't really match any pattern that you've seen before or any problem that you've seen before. And so you're
Mhm,
basically forced to dissect the problem.
mhm. Yeah, so I guess I want to go into that. Yeah.
Okay, you want a mechanical skill problem. All right. Okay, so let's avoid trees for now. Let's pull up the problem database, and I think this is a pretty. I'm gonna try to avoid a problem that I've asked other people before, but I
Mhm.
think for you, based on what you said, I might have to do that again. So let's take a look at. Cool. Can you check if you can type in that?
Um, yeah.
Oh, you can type? Cool.
Yep.
All right, let me get the timer out. All right, ready? Set,
Yep.
go. All right. So, we're going to check if any two intervals overlap among a common set of intervals. So an interval is represented as a combination of start and end time. Given a
Mhm.
set of intervals, check if any two intervals overlap. So in the first example that I give you, 1, 3, 5, 7, 2, 4, 6, 8, the intervals 1 and 3 and 2 and 4 overlap at 2 and 3. And then if I gave you the second example, 1, 3, 7, 9, 4, 6, 10, 13,
Mhm.
none of these intervals overlap.
Okay. Um, and are there any other constraints with the input that I should know about?
Well, what do you think? What do you think is reasonable here?
Okay. So can the array be empty? I guess.
It could.
So they're non-empty, right?
Mm-hmm. Just assume. Ideally, your code should be able to handle the empty and non-empty cases. But let's
Mhm.
suppose that for the empty case, that it returns false because there are no intervals that overlap.
Sure. Um, so we're supposing that the arrays are not empty,
Sure, you can do that.
and are we um, are we dealing with things like I guess infinity or negative number within our array?
Um, you can assume that it's the full range of integers.
Okay, so only integers,
Mm-hmm.
and all the intervals would be need to be valid, right? Like the end time will be greater than the start time.
Yeah, that's correct. You can assume that these are all well formed.
Okay, so all all valid intervals. So with that, the requirements would be we're given an array and we need to check if the two intervals overlap. Um, so let's see. Um, I think, yep, definitely the first thing that we can think of is to do a do it in the brute force way, like compare each interval, like does the um, and to see if they over compare and every pair of intervals in
Mm-hmm.
the array and to see if they match.
Mm-hmm.
So that would take like order n squared time.
Mm-hmm.
Um, I'm just write down it in a brute force. Um, take order n squared time, and how we're gonna do is to compare every pair of intervals. Um, other than that, um, and the way that we're gonna compare the intervals would be, so let's say we're given 1 3 and 5 7, and how we're gonna um, check if any two intervals overlap. Okay. So does that mean, yeah, so I guess I have another question about the input. So we can return true like if like as soon as we find two intervals that overlap, right? Like we don't need to specify which intervals are they.
Mm. What do you mean?
Like we only need to return true or false,
Yep.
but not really
You
putting
don't
it.
need the interval. You don't need the overlapping intervals themselves. You just need true or false.
Okay, yeah. Um, so with that, like, so we have the two start times and end times um, where of these tuples, and we'll check if um, I guess like for like the start time for the first would be 1 and the other would be 5,
Mm-hmm.
and the end of the first one would be 3 and for the other would be 7. So um, I think um, if we're looking for an overlap, we would need to take the we would need to take the bigger number between the start times and the smaller numbers between the end times. Like if they were to overlap, then that would be the case. Like like here we would have to start with the max of 1 and 5, which in this case would be 5, and and the minimum of the n, which in this case is 3. And in order for two intervals to overlap, we would need the start time to be at least equal um, or greater than the end time. So um, and we will consider two intervals that overlap at just a single integer to be that would be a true case, right? Like if it is like 1 3 and 3 7, that would be true, right?
Mm-hmm. Wait,
Okay.
1 3 and 3 7. You mean if they're on the edge?
Yeah.
Consider them not overlapping.
Okay. So yep. Thank you. Then I guess with that being said, then the only valid case would be when start is smaller than n. Um, so that will be how we check the how we check if they overlap. How how to check if they overlap. So that's an example that I have here. Um, and with that being said, then after we run through everything, if there are no pairs that overlap, then the loop will return false. Otherwise, it will return true sometimes in my nested for loop. Um, and now let's think about how we can optimize this further. So instead of doing this like Um, the brute force way, I think one way we can do is to sort the array first, um, because it seems like if like let's see if we can sort the array. What would be like if we sort the array by the start time? So 1 3 2 4 5 7 and 6 8. So here we have a sorted arrays by the start time. Sorted by start, and then we'll see. Let's see if we have so let's see with this reminds me of 2 pointers. So I think I will try to see if we can apply 2 pointers here. So let's say we have the I to start at 0 and J to start at 1. So now we would need to check if 1 3 and 2 4 overlaps. It is, yeah, and it does seem to be the case. So so right after we sort this array, then we know that then the first pair that we check will be an overlapping pair. So we'll do that. But this seems to be too good. Yeah, this seems to be kind of like a happy case to me.
Okay.
So I think let's try to generate an example where they don't overlap. So let's say 1 5 and then 7 10, or yeah, I'm gonna try to make this a little bit trickier with like 1 1000 and then something like 5. Oh no, these were overlapped. Sorry. So let's try to have 7 10 and then like 9 11 and something like 11. Yep, let's see, 11 and then 15 and 14 18, something like that. And we will, yeah, I think we can like if we apply the algorithm here. So we start, so the pointer would be we all start with 0 and 1 like the previous example. And what we'll do is for when we check the first pair 1 5 and 7 10 and we see that start n minus start is like n minus start is, so the max n, the max start, I'm sorry, would be 7 and the minimum n would be 5. And because we have that max start minus min n to be max start minus min n is -2, so that doesn't work. So because of that, now we want to increment the smaller interval, which in this case is 1 and 5. And 1 and 5. So we increment it and we hit 7 and 10. But I guess if the first interval, if the first one doesn't mm, if it doesn't, the so we might not necessarily have to use two pointers here. I think an easier way to go about this would be like, because we can see here that if the first and the second, like, let's say we're at the first and the second indices, and if they don't overlap, then we know that we need to move on to check the second and the third elements, the second and the third intervals, to see if they overlap.
Hmm.
Um, like the start time, because like the start time would increase as we go towards the end of the list. So there's no way that we can find a match towards the end.
Okay.
Um, so I think it is just a matter of incrementing the incrementing our index, and check with the element right next to it. So we would check 0 and 1, and if it doesn't work, then we check 1 and 2, and then 2 and 3. So yeah,
That sounds
and
fair.
that should be the way to go. Um,
Okay.
so that is how good.
Yeah. So what's your runtime complexity?
Um, I think with my runtime would be order. So first, to sort the array, I'm sorry, that would be in the order of n log n,
Mm-hmm.
and to traverse the array, that would be order n.
Mm-hmm.
So the overall time complexity is um, order n log n time plus order n, and it's n log n.
Okay. So seems like you have a pretty good idea of that. There is one other way of doing this. Do you think you can get faster than order let n log n for your runtime?
Mm. So are you asking if there a better way than on n log n?
Yep.
Okay. So so we need to go down from n log n to, I guess the next best thing would be um the better thing actually would be order n. So if we want to get this to run in order n time, what would that look like? Hmm. So in order n, that seems to me like using 2 pointers, or yeah, um, if we, let's see if there are some sort of patterns that we can see from these. Like if I have like but these are not sorted, so let's see if we can work with the unsorted arrays. um, 7, 9, 4, 6, and 10, 13. Can I think about it just for a second?
Yeah, go ahead, do what you need to do.
Yep, thank you. 4, 6, 10, 13. And we're basically trying to see if we can reduce the time to n to n. And it just so I think um like for what we have in the input, like because it's an unsorted array, I don't think there's a reasonable way that we can get order and time without like the best thing that I can think of is to sort first and then go through the list. So I don't feel like we can do better than order and log n.
Okay,
Yeah.
let me make this more clear then. Suppose I gave you something like 1, 2, 3, 4, 5,
Mhm,
6, da 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 da, all the way to 99, 100.
mhm.
So basically, here we have 50 intervals.
Yep.
So, do you think you're do you think this is the most efficient way of handling something like this?
Um, so in this case, we have so is this an input that has already been sorted?
It doesn't really matter. The point I'm trying to make is, what if I crammed a bunch of intervals in here? Do you think it's still the most optimal solution,
Um,
even if it is sorted? Yeah, let's suppose I gave it to you sorted.
mhm. So I think going for yeah, with like 50 intervals, so we have something, the runtime would be like 50 log 50 for sorting the array, and then 50 to go through the array.
Mm-hmm.
And then it seems like if we uh, compare uh, uh, like with this one we can just like if we had 1 2, I guess, if we're comparing 1 2 and 3 4, um and then we want to look for something that can match with, so after we, so let's say if we're at 1 2 and 3 4 and it's a mismatch,
Okay.
um and so the so we would need to move on to from the mm, like I guess yeah, I think I'm getting stuck here. Like, could you give me a hint?
Okay. Sure. So you said that you need an order n. You need something order n, correct?
Yeah.
So which means that you're forced to iterate over the entire array, but you cannot do like every you can't compare every interval to every other interval, or else that would get you to order n log n. I mean, sorry, and that would get you to order n squared. And you can't do a sort because sorting takes order log n. So which means
Mm-hmm.
that you're forced to actually, do an iteration of it, and then be able to record it in a meaningful way, and then iterate over it, record it in a meaningful way, combine it with whatever past data that you have, and then
Mm-hmm.
until you get your answer.
Mm-hmm. Okay. Compare with the past data. Okay. So let's see if we can. Yeah. Thank you for that. And
Okay.
now I'll see if we can work something out from that suggestion. Um. So let's see, we have we have an array that looks something like this, and we're not relying on sorting of any kind. um, So let's see, we start 1, 2, 3, 4. This is a mismatch. What kind of information do we want to record from this? So maybe a smaller interval. So let's see if we can do like a smaller interval and a small and large and group intervals. So so small one right now I have 1, 2, and the large one, large I have 3, 4. And then somehow go through when I go to the next index, which is 5, 6. So let's say we're doing like we're going this iteratively, and the next thing we encounter is 5, 6. What we will do is we will should we check against both the small and large interval, or is it it is the largest thing that we have seen so far. So let's say it is larger than the largest thing that we've seen so far. And so it belongs to the larger group. And so
Again, just to clarify, that the input data is not necessarily sorted.
So I think, yeah. So can I just go back to our original example that we have in the beginning?
Why not?
Okay.
Yeah.
So let's see, this is the data that we have, and let's go. So my current idea is to have some sort of like maybe an array to hold small and large ones. So first we compare 1, 2, 1, 3, and 5, 7, and it doesn't, and those two don't match. So I'll put 5, 7 to the large, and small one would be 1, 3. And now I move on to the third element, which is 2, 4.
Okay.
And with 2, 4, we see that it's smaller than the large one, we've seen. So put it in 2, 4. So it looks kind of like a stack.
Wait, hold on. What is this trying to do? Why do you do small versus large?
I guess I'm just trying to see if like maintaining information about maybe like kind of like the smallest or the largest we have seen so far would help in some way.
Okay, so what do you mean by smallest versus largest?
Like so I guess more versus large, it should be more it doesn't really seems to go anywhere. I think we can look at instead of looking at small and large in terms of like, so I'm thinking of them in terms of the start time. But I think because we're using the tuple here, so maybe the data that needs to be stored should be the start and the end time instead. Like some sort of like if we're doing it like in our comparison, we're trying to compare the largest start time that the largest start time versus the smallest end time.
Okay.
So does that can that be applied here? So
Maybe.
let's see if I have the start time and the end time variables. the start time goes from, so let's see if I'm just going to try to apply my method for
Sure.
comparing intervals to see if it works here.
Hmm.
So the start time, so first we have 1, next thing we have 5, so we update 1 for 5 to replace 1. And the next thing we see 2, so 2 doesn't really work, so we just get rid of 2. So we don't consider that. And mm, uh, and for the end time, the first one we will have 3, and um, the and after, so this is after we go through the first 2 elements. So when we come up against the third one, we will have the start time should stay the same,
Hmm.
but the end time would now be 4. Yeah, the end time would now be 4, and it's still okay. So now we have a little bit of trouble.
Okay, you're coming up
We
on about 29 minutes here. Let's in this for the purpose of this interview, let's actually code the sorting thing that you mentioned,
Okay, sure.
and we'll come back to this later.
Hmm. Yep. So I'm gonna do this in Python.
Sure.
Would that be okay?
Sure.
Sure. Yep. Thank you. So I'm just gonna do so assume that we have something like def and overlap, and the input is an array. Like, can you see my
Yep.
mouse pointer?
Yeah,
Okay.
I can see you highlighting the def.
Okay. So check overlap. The first thing we will do is we will sort the array first. So we use the sort library in Python.
Sure.
Sort, yeah. So that would be, so this one will sort the array in place.
Mm-hmm.
So we can just use the array after it's sorted. And the next thing we would do is to run a for loop for I in range of length of array. And what we'll do is we will actually that should be lang -1 because we're checking against the thing next to it, so it should be lang -1.
Sure.
And we check if, so the start would be the maximum um, of r at I at 0 versus r at I at I plus 1 at 0, and the n would be the minimum of r at I at 1 and r at I plus 1.
Okay.
So if start is smaller than n, then that means we found a match, and that means we can return true. And so does it matter if it's just kind of like auto?
Yeah, you can do whatever.
Okay. So if start smaller than n, then return true. Otherwise, we just move on to the next thing. And after the for loop, then when we break out the for loop, then we know that we didn't find any match.
Mm-hmm.
So that should be false.
Okay.
Yep. So do you want me to go through an example with our input here?
Sure. Why not?
Okay. So let's see, we have 1, 3, 5, 7, 2, 4, and 6, 8. And the first thing we'll do is to sort them. So I think I have a sorted array somewhere up here. So I'm copying that over. Yep. Um, so we sorted for I in range of, so first it will start at 0. I will be 0. So the start would be the maximum of RA00 and RA10. So that would be 1 and 2, so maximum 1 and 2, which would be 2. And for the end, it would be the minimum of RA01 and RA11. So that would be 3. For the minimum would be 3. And we see that that is a match. So we start smaller than n and we return true. And with another case, like the one that, yeah, so the one that there doesn't seem to be a match. Um, um, so actually something that I'm not quite sure about is if I were to start a tuple, if I were to start like tuples should like will and like tuples of integers, like would that automatically sort them in by comparing the numbers
I'm not a
if the
Python
tuples.
programmer. You should know this one.
Okay, so yeah, so because I'm not quite sure about that,
Maybe something you should clear that up and understand that first. Yeah.
yeah, uh so I'm not quite sure. Yeah, I'm thinking that we might need to write a custom sorting function here, um, because um, like just want to make sure, like in an actual interview setting, like would we have access to documentation of any kind?
Yeah. In an actual interview, you wouldn't be able to look it up. You would just have to be forced to know this off the top of your head. The Java
Okay.
equivalent of this is to insert a comparator, which is like a callback object that's used to check two objects to see what they're ordering. That's it. But I'm not sure what
Mhm.
it's done in how it's done in Python. So if you are using a programming language for an interview, I expect you to know it pretty well. That you should know something simple like this.
Okay. Um, so I guess because I'm not I'm not quite um sure if that is the case with Python. Um, then let's see. Yeah, yeah. I guess for that part, I would just do I'm just gonna do like a custom sorting function.
Sure. You know what? I get the
Or
idea. I understand what you're trying to do here. Okay. I mean,
yep.
technically that is the right answer. You didn't get the optimal one, but you're at 36 minutes in. Do you want to stop here and go over it, or do you want to still keep trying?
Um, so yeah, I wanna keep trying to see if I can get to the optimal solution. Yeah, if you have time.
Okay. Yeah, I'll give you another 5 minutes.
Okay. Yeah. Thank you. So let's see. We're going back to yeah, to our idea of storing some data, storing some past data, and require information in a meaningful way. So what would be that? I think so. Rather than um, the largest start time that we have seen so far, I think we should. Um, mm, mm, mm. So what if we use the small start time rather than uh, so okay, so let's see if I can let's see if we, so rather than using the largest start time, then I will use the small start time, min start time instead. Min start, and the minimum n, uh, or max start min n max start and so okay, or max start, or still, I think we should still, yeah, I'm still gonna go with the idea of max start and minimum n. So where I start to be 5, and then next one would be 2, so that doesn't affect the start time. And then the next one, the start time would be 6, and the minimum n appears to be 4. Still doesn't seem like an overlap. Or what if we were to store all the, what if we were to store all the start time in a stack? I think like this, the stack of start time would look something like 1, 5, 2, 6.
Okay.
And the end time, the stack of end time would be 3, 7, 4, 8.
Okay.
And then let's see if we're trying to find we're trying to find the match between any two, so for yeah, I guess I don't really have like a clear idea of how to process with this right
Yeah.
now, so
Okay,
yeah.
that's fine. We're coming up on 40 minutes anyway. How do you think you did on your interview? Just curious. How do you think you did?
um I think because this seems to be kind of like and yeah, like on the easier side, I feel like, so I shouldn't have got kind of like caught up in the part of figuring out what to do after sorting the two arrays. Like it yeah, I guess that could have definitely been better. Like I should have realized that I can just iterate through the arrays and compare every two like two elements next to each other,
Mm-hmm.
rather than getting caught up into thinking about the about doing two pointers. Like that was just kind of random, I think.
Mm-hmm.
And other than that, um, I guess I might not have enough solid base to come up with the optimal solution,
Mm-hmm.
like you were expecting.
Yeah.
So I think it was kind of like yeah, below, kind of like below average ish. Yeah.
Mm-hmm. Yeah, that's pretty much it. Basically, what hopefully you saw there was that yeah, anyone can get like the sorting algorithm one. I think, um, the harder one is being able to get the other alternative optimal solution. And the only reason why I say it's alternatively optimal is because, much like how n versus n log, it's like kind of how log n versus n. There's a break even point. You should be able to get either way. You should still be able to get both the solutions. So let's go over what you did like with the first 15, 20 minutes, and then let's go from there. So you can see the timer on the bottom. Let's go through here. Okay. Okay. So, let me move the controls away. Can I even move it off? Guess not. Ah, there we go. I can at least make it smaller. Cool. So, first, yeah, first 6 minutes is like, okay, you're just trying to understand the problem. Although I think a lot of these conditions are pretty pointless, only because in a sense that you're not asking necessarily the right questions. I mean, I get you're trying to ask clarifying questions, but they're also pretty frivolous in my opinion, only because they don't really contribute or clear up any ambiguity. They just really eliminate your work. Like for instance, all this only integers, all valid intervals. It just means that you're not going to have to handle some edge cases more so than just
Mhm.
trying to figure out whether or not you are have to go one algorithm or another. And
Okay.
so because of that, I mean, I'm not. Don't get me wrong. I think it's okay to ask this, but it just like does nothing in the grand scheme of things. It's just like it's just a waste of time, and definitely can get you around some work. But it's like most of these questions that you'll be asked, they kind of expect you to handle the error case within the code that you write. So even if I
Yeah.
gave you an array that is nothing, like that's empty, then
Mhm.
you should be able to handle that. The valid interval one is fine. I think I'm just out of all these, that's really the only question that is really useful. Because if I gave you an one that was not well formed, then it would make it complicated. So that is probably the only really good question that came out of this. So you
Okay.
identify the naive solution, perfectly fine, cool. That's how what I would expect. You're going off and testing it, okay. Um, start versus end is less than end. This one, it's be a little more clear on this one because this is not. Yeah, this is not exactly clear. I think what you meant to say was that the first interval that you're checking's dot end is less than the end dot start.
Hmm.
Yeah, so I want you to be more clear on that one. That one was just like I already knew what you meant, but this is your communication failure right here.
Yeah.
And be more atomic about it. Be more mindful about like these variables that you're naming because yeah, these are starts. Like you call it start and end. I would have gone with A and B
Hmm.
as A and B naming convention, only because you already have start and end being like the first interval, the first array and second, the first element and the second element in the array. But you kind
Hmm.
of abandon that later on, so it kind of tells me that your thoughts are kind of like scattered and jumping around. You're not really sure what to aim at. So that is, I mean, it's a little bit of a problem, but it's not the main problem here. These are just little inefficiencies that they do start to add up and interfere with your thinking once you start going to harder problems. So just be more aware of this. Be more consistent in your convention and what you refer to things as. So okay,
Hmm.
so it's 10 minutes in. Uh, sorry, I'm gonna go back a little bit. At around 8:44, you start mentioning two pointers, and I'm
Hmm.
wondering why. What about this problem gave you the impression that it would be two pointers?
Mm. Yeah. So I guess usually if we're working with two pointers, most of the problems that I've seen so far, like that should involve like two arrays, like kind of like two sorted ones or like two sorted linked lists and something like that.
Mm-hmm.
Like if we're trying to find if there are like if we're trying to find like kind of like duplicates within two sorted arrays.
Mm-hmm.
Uh, so those are the cases that remind me of the two pointer techniques,
Okay.
or like something like I guess the minimum window substring, the
Mm-hmm.
sliding window one.
Okay, I see what you're saying. Yeah, so okay, you're just doing it based on data structure and then just throwing a pattern at it. Um, that's not very efficient because there are so many patterns out there. Again, you could have applied sliding window to this randomly. You could have applied two pointer. You could have done a whole lot of other algorithms. And so that's pretty
Hmm.
inefficient because you're throwing patterns based on a data structure, but you're not using it based on anything else that you see. Usually, when you use two pointers, you are trying to compare two elements, but
Hmm.
they are you're moving forward in the list instead of trying to compare every element to every other element. It's just more like an optimization on top of that. And in this particular case, what you should have been doing is identifying what kind of element that you needed to identify with each other. And if you sorted it by start, then you all you needed to compare the element, one element to its next element. And
Yeah.
that's what you ended up realizing that, oh, wait, I don't need two pointers. So I would definitely clean up your approaches to which patterns you use to make it more clear cut. Because it's not enough to just say, oh, I'm going to use an array. And then let me try out. It's like, oh, I have an array in front of me. I need to try this pattern out. Oh, well, this pattern didn't work. Let me try another pattern. Let me try another pattern. And if you remember back in my guide, what I said that this was actually pretty a pretty inefficient strategy because you end up burning a lot of time here.
Mm-hmm.
And so if I bring back up the timer, so you take a look at this, da 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 da, and I think around 8, yeah, around here 8 minutes, and then you propose at around 8:44. Yeah, 8:44 is when you start proposing it, and then you're trying to verify it. And then I think around like 10 or 11, 10 minutes or so, you finally realize that you don't need it. So I mean, it's a small thing, but every minute counts, you know, like
Yeah,
in these
for
interviews.
sure.
So it's like it's 2 to 3 minutes that you spent just trying to test it, and then I think, yeah, you just end up realizing you don't need it. So okay, then here you
Yeah.
finally generate some examples. This is actually the first thing you should have been doing. Like
Mm-hmm.
when you're here, I'm trying to generate some examples of how to actually do it, or at least like try to prove this idea. I actually would have done this first, proven the idea first
Mm-hmm.
instead of trying to come up with like 2 pointers or whatever. So in general, you already knew it was going to be starting. Then I would have just iterated on this, and then you say, okay, it's a happy example, fine. And then you try this example. This really doesn't add very much, I don't think. Only because you're guaranteed that it's sorted, and then you'll have to look at the intervals right next to each other, right?
Mm-hmm.
So all you had to really do to prove this case was really just come up with all the possible configurations that you could have the interval at. And what I mean by that is all the different ways that they could overlap or not overlap. Like if I call this interval A, actually let me actually type up on the document, and I'll show you what I
Mm-hmm.
mean.
Yep.
So let me bring that document up. So here, so you talk about like this example, right? This is not any more meaningful, not more meaningful
Uh-huh.
than the previous one,
Yeah.
because this is like, it just means the only difference between this and this is that there are no overlap. There's still an overlapping interval. It's just at a different position.
Mm-hmm.
So how I would have done this is like if I had a dot start, a dot end, b dot start, b dot end, and then I would have just drawn all the different possible ways that this could have overlapped. So for instance, if I have b here, a, oops, and then here would be something like this. You know,
Uh-huh.
just go through every single possible ways that they could overlap, and then just prove that whatever I just proposed would work.
Okay.
So something like, yeah,
Yeah.
you know, something like this, and just keep generating it.
Mm-hmm.
Because again, you're only ever comparing these two. So
Mm-hmm.
the only thing, and once you did that, you would have also realized that hey, you only need to look at the end of one interval versus the start of other one, which is what you did, up here. And so actually, I don't know why, once you declared this and once you figured that out, why you decided to do something more complicated than this. Do you understand where the
Like,
disconnect is?
oh, okay. Yeah. So, yeah. I get what you're trying to say. So I guess let's just do yeah, it can just be um start of the first one and end of the other one.
Mm-hmm.
Yeah,
Well, the bigger
because
point.
there's
Mm-hmm. Go ahead. What I was saying is, it's more than just understanding what the answer is. It's about this
uh
disconnect between your design and what you're writing in code.
uh
It's like you've already figured it out. Why do you need to do the? Why do you need to do this? It makes no sense. So to me, it just sounds like you had some idea of what you wanted to do, and then you just kind of haphazardly just went into it, and then just like kind of, oh well, and they started maybe doubting yourself for a split second, and then just ended up with this. Does that sound about right?
um I think that was actually my original idea. Like I want, like, when I have two intervals, then I was kind of looking at like the the better start like the larger start and the small end. But okay, yeah. Now that I think about it, then if we have a sorted array, then that is the guarantee thing. So no need to do that again.
Mm-hmm.
So I guess because I didn't go through, go through that like what you said, generating all the possible cases where they can overlap.
Mm-hmm.
That I didn't really realize that I don't need to compare them again. I don't
Right.
need to compare to get the max and the min. um like I guess I was kind of getting stuck with the brute force solution. Like
Mm-hmm.
I'm just comparing max and min again, but that was definitely not needed.
Yeah. So I mean, that's what I mean by generating examples. It's like just making sure you cover all your cases.
Yeah.
So, and I mean,
um
sometimes you're gonna miss some cases. That happens, but it's what's more important is that you're able to actually think and prove your idea here. So,
mhm.
anyway, you ended up just like see how quickly I was able to do it. Like it was like 30 seconds to a minute, and then you immediately
Yeah.
realized what your mistake was. So if you did
Mhm.
that, you could do that as well. But the point I'm trying to make here is that even though it seems like a small amount of time, these things end up add up and eventually prevent you from actually making further progress in a problem. So these little things that you clear up in the beginning will make solving problems a lot easier in the future. So.
Uh-huh. So I guess like to kind of like put that in a more concise way would be, um we try to generate the examples in the beginning and like really look into the input rather than kind of what I did was throwing random patterns, but I should have kind of like worked on generating inputs, see the pattern, and then apply the correct algorithm. Is that what we're supposed to
It's
do?
almost there. Well, the point I'm trying to make is that once you have an idea, you need to prove it first before you even think about writing the implementation or even writing the code. You know,
Uh-huh.
it's really just like,
Yeah.
okay, you have this idea of sorting and then comparing, and then it's
Uh-huh.
like, well, what does that look like? What does the comparing look like? And so generating these examples just shows you, hey, if I'm going to compare, these are all the test cases that I need to prove it against.
Yep.
And being then just looking at that, then you could already realize, hey, wait a minute. The common thing is that this end case is this end marker is greater than the start marker.
Mm-hmm.
Although this is technically not right. This is not a correct example because A should always be less than B. So the only other possible case here would be that if you had something like this.
Yeah.
So just based on that alone, you should have already been able to just like it's literally just three cases. So
Mm-hmm.
all right, let's go back to the code. Let's go back to your video now. We're gonna keep going. 50 intervals. Okay, sure. This is where I'm starting to give you the hints. I think. I don't know. I jumped, but let me look back at my notes. Okay, so at around 15 minutes, you actually finally get to your n log n solution and you prove it. Fine. So between that, so you spent the first 15 minutes coming up with two solutions. Fine. Although I would have said if you're gonna do the n log n solution, you should have lost at least like 3 minutes already. So you should have already been at this should have been 12 minutes instead of like almost 16 minutes.
Yeah.
Yeah. So it's just inefficiency here. That's it. But again, every single moment counts in this interview.
Sure.
And so here, then you start trying to, this is where you start getting in trouble. So
Yeah.
you start trying like random stuff here. Um, you're not really sure what to do here, and so you have to ask for the hint. And like, okay, here. And so notice like here, between for like the last 3 minutes, you kind of just didn't try anything or really type anything out, and you were just kind of saying, oh yeah, I don't see it. When I told you it's like n order n, then it's like okay, fine, I'll give you an example here. I think that's might be fair, but I would not. I'd be leaning on the side of okay, this guy is not. How do I describe it? This guy, when I present something like this, it feels like you're not giving the idea a chance.
Mm-hmm.
You're not trying to see in what world this would be a an alternative would be more useful.
Uh-huh.
And because of that, that's a little bit of a red flag. It's not the end of the world, but it's just not good. Like
Okay.
if you can't see it, then it's always good to just ask. I'm trying to see in what world we could go to n order n. N log n seems pretty efficient to me. So what could where like what situation could this be more optimal? I mean, obviously order n is going to be is more optimal than n log n, but at least you need to show some kind of thoughtfulness and give the idea a chance.
Yeah. So I guess I'm a little bit unsure about that. So,
Mm-hmm.
um, like my thinking would be, order n would always be better than n log n.
Yep.
Um, but like I guess are we kind of like thinking about, because when we reduce the runtime, then it's possible that we also need to make some space trade-off.
Mm-hmm.
So that would be like, so kind of like the optimality that we're talking about is
Mm-hmm.
like getting a better runtime,
Mm-hmm.
but like more space trade-off.
Yeah.
Is that, yeah, okay.
Yeah, like the thing is that I never said that that it had to take up less space or the same amount of space. I said, can we get faster? And
Hmm.
so you would have had to, if you pointed that out, then it's just like okay, well, in order to do this, we might have to increase the memory usage, and then I could confirm or deny that with you, and that would have been your hint right there.
Oh yeah. So
So
yeah, that's definitely helpful. Yeah, thank you.
yeah, yeah, and plus that, how everyone talks about like being able to identify trade-offs. Well, this is one of them. Isn't that a perfect opportunity to say, hey, wait a minute, if we're going to do this, we might need to give up some space.
Hmm.
Yeah. So this would have been a very perfect time to transition and get a hint from your interviewer.
Yeah. So I guess rather than just saying, "Oh, I need a hint," I should have said, like, I should have thought about like why, like what kind of specific hints that I need,
Hmm.
rather than just saying like, "Oh, I don't know how to do this. Can you kind of like throw idea at me?"
Yeah, basically that's the basic idea. I mean, there's more nuance to it, but you can think of it as at least acknowledging the trade-off of what you're giving up in order to improve your runtime, and say, hey, this
Yeah.
might be a possibility. Just acknowledging
Hmm.
that is already good. Is already big points.
Yeah. Thank you.
So okay, so I'm giving you the example here of 50 intervals. Well, you sorting just all these 50 intervals is pretty wasteful, right? Especially if they're already sorted to begin with.
Hmm.
So in this particular situation, you might be able to get, and you can still run in order n. Like even if this wasn't the case, even if it wasn't sorted, you still get there. And
Hmm.
so after this, I don't think there was really a you're just trying random stuff here.
Hmm.
At this point, you have no structure in your thinking, and this is basically a consequence of how you practice.
Yeah.
So, and just to prove my point, like yeah, you're trying this idea, trying this idea. There's not really much to say here because at this point you haven't really don't have any structure on how to actually think about these problems. So watching the rest of this is kind of meaningless. It's just watching you
Hmm.
flounder.
Yeah.
So let's go over to when you start coding.
Hmm.
So there's not really much else to say here for the coding part. Um,
Yeah.
it's like sure you write the code, that's fine. Um, wow, that video's got laggy. Okay. Okay. So I start you at like 29 minutes, and then it takes you like 10 minutes to write the code. I think something
Hmm.
like, yeah, yeah. So here you're like sort array, length, start, end, start false. Yeah, like okay, so it takes you like maybe 4 or 5 minutes to write the code, fine. I mean, that's fine. The thing, especially the code's very simple. I would have expected this to be a little bit faster, but this, again, we've already pointed out how this start and end here just kind of, it's not really correlated to like the
Yeah.
optimal solution. And I already showed you how to get rid of that, so you already know what to do here. And you spend
Hmm.
like 5 minutes proving the example. Okay, fine. And then you go back. All right, so that's all it is for what that's everything I have for what you did. Now let's actually show. Let me go show you show you how I would think about this
Yeah.
other solution. So let me go back to where I am and let me mark up what I'm going to write in red.
Hmm.
So if I'm in your shoes, I'm looking at this and saying, okay, well, order n means I must iterate, right? I am forced to iterate. I mean, given and also based on the hint that I gave you.
Hmm.
So I'm going to just mark this up. So I need to iterate. Need to iterate a finite amount of times, and because what order n? Oh, why is it not? Hold up. Why is my text not changing to red? So order n, order, which is approximately equal to order 2n, which is order to order 3n, dot, 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 dot. As long as it doesn't rise, as long as that factor doesn't scale with the number of intervals I'm given, then I'm fine, right? So,
Mm-hmm.
the question is, well, what do I need to get on the first pass, the second pass, and the third pass? So at this point, I already know two things. One, must iterate,
Mm-hmm.
and with every iteration, I need to record. Yeah, I need to
Mm-hmm.
record something, and then be able to transform that into something else. But I'm going to assume that I have given an unlimited number of space for at least for now. We can always optimize over this, but I'm going to assume infinite space. Can
Mm-hmm.
always optimize later. So the way I would do this is okay. I'm looking at 1 and 2, 3 and 4, and then going back to my examples, I'm going to say, hey, wait a minute. If I do it like this, da 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 da. I'm going to go here, da 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 da. So at index 0, let's say index 1, 2, comma 3. And then what does this look like if I give it at 3, comma 4? I say, hey, wait a minute. I can do this as an array. And then I just have at index 1, I have it equal to 1, index 2 equals to 1, index 3 equals to 2, because there's two elements there, index 4 equal to 1, right? And if I ever see something like 2 here, then I know that this must be a overlap.
Mm-hmm.
So this would be what my key insight is. And now, we haven't really done anything so far yet, but because if I just started creating an index of 0 to max element of array, then what ends up happening is I have to go through every single interval, and for every interval I have to populate one in between. So if I have 1 and 2, so I have to have 1, 1 here, and then 1 and 2, and then 3 and 4.
Yep. Sorry. Can I just cut you off there for a
Sure.
second?
Is there something that's
Um.
clear?
Yeah. So I guess I'm kind of getting lost at the part where you explain 1 equal 1 and 2 equal 1. So can you just go over that one more time?
Sure. So let's say I represent I have these intervals, right?
Uh-huh.
And so these intervals mean that at index 1, I have something. At index 2, I have something. At index 3, there's something that exists, right?
Mm-hmm.
Or I should say we
Like,
have one, two,
like so
three.
the indices. Oh, okay.
Sorry, my bad. So let me say I'm gonna do it like this. That's my mistake. So if I said 1, 3, 3, 4, so if these were to overlap, then I understand that at index 3, if I run a counter, then there will be two elements there.
Okay. Uh-huh.
So as long as
So,
I see that, then
uh-huh.
I know that it must overlap.
Okay. So, are we kind of like just like enumerating all the numbers in the intervals?
Uh, not enumerating. It's more like we're keeping track of what indices are covered by an interval.
Mm-hmm.
Does that make sense?
So yeah, the indices. So like for like if we're talking about 1, 3, and 3, 4, then the indices covered, like you said, would be so 1 is covered by 1, 2 is yeah, I guess okay. So 1, 3. Yeah, I'm still not really understanding what the indices here mean. So
It's the
yep.
indices that the interval covers, right? Because
Uh-huh.
if an
So
interval from 1 to 3, that must mean index 1 is in there, index 2 is in there, and index 3 is in there, right?
yeah,
And so that's what that counter is.
okay.
So if I take just one interval 1 comma 3 here, then what this
Uh-huh.
says is just that it is equal to 1, and then
Okay.
4 is equal to 0.
Uh-huh.
Does this make sense now?
Hmm. So yeah, we're just going through like kind of like all the numbers in like between those two numbers, right?
Mm-hmm.
or oh, okay, yeah, I think I see what you mean now. Yep.
So in this case, there's only one interval that we've taken so far that covers index 1, that covers index 2, covers index 3. So
Oh, okay. Yeah, that makes sense. Thank you.
yeah, so then now let's say I take index 3 comma 4 on top of that. So which means that I'm going to add +1 to here, +1 here, because there are now two indices that cover the two intervals that cover this index.
Mm-hmm.
And then there's only one interval that covers this index.
Yeah.
Right? So this is just a reflection of this idea up here.
Uh-huh.
So, and as you can see, hey, wait a minute. If I see 2, then I know that this means more than one interval covers this, means overlap. So if it's greater than 1,
Mm-hmm.
my condition is greater than 1, because I could also have 1 and 4 as well, right?
Mm-hmm.
Which I mean +1 here, and then another +1, and so on and so forth, right?
Mm-hmm.
As see, so that is basically the gist of the idea here. Now,
Uh-huh.
so what does this mean? This means that, well, I can't exactly keep doing this for every single interval because I'll be going through n number of intervals,
Yeah.
and then for every single one, I'm going to be n number of intervals, and then for every single one, I'm doing an operation that is of order n, because, or I should say order n max elements,
Mm-hmm.
max, or say max index.
Mm-hmm.
Because these intervals must exist within the max index, or in this case, which is 100. And so basically, this doesn't really. This goes back. This is more on the order of n squared, just doing this.
Yeah.
So this is not much better. But what have we improved on this? So instead of just counting these, well, the next thing I can do is, well, the only thing I really need to keep track of is the start and ends, right?
Mm-hmm.
So all I need to do is just mark when these intervals start and when these intervals end. So at index 0, there's nothing that starts at 0. At index 1, there's one interval that starts here. Interval 2, 0, 3. Now there is we'll call it a -1 to mean that interval is an end,
Mm-hmm.
right? Because the moment I go back, it's like index 4 is equal to 0, so on and so forth, right?
Mm-hmm.
So then I can just do this again here, where once I have a index array 1 4 +1, and then add +1, right?
Mm-hmm.
So I mean, technically this is not really the greatest example because I did say that if no, sorry, I said 1 4, right? So
Mm-hmm.
so that means that at index 1 and 4, here +1, 0, 0, -1, and then here would be -1. So I said 1 to denote that it's n. So before we had 0, 3, and I'm adding 1, 4.
Mm-hmm.
Or did I say 1, 3 or 1, 4? No, sorry, I said 1, 3. My bad.
3,
Yeah,
right?
yeah. So are you starting to see what I'm trying to get at here?
Okay, so yep. So at one, so like when we're at 1 3, then we increment 1 plus 1,
Mm-hmm.
and then 3 plus 3 also be 1,
Mm-hmm.
and then once we hit 1 4, so like for all the indices, are the initial values of them be like 0?
Mm-hmm. Yeah. So, but this is like, okay, this is pretty obvious. It's still kind of like the same as what it's up here. So what happens if I change it to here? Then that means that 0 gets index 2 gets 1, right?
Uh-huh.
But that means that these are still overlapping.
Mm-hmm.
Does it make sense why?
So they're not overlapping because we haven't got any 2 yet.
Well, that's based on the old condition. So you would agree that intervals 1 and 3 and 2 and 4 overlap, correct?
Yeah.
So What do you notice here?
Um, so 1, 2, 3, 4. Uh, so the um, so the okay, so the 1 indicates the start, and the 3 indicates the end,
Mm-hmm.
and the -1 indicates the end.
Mm-hmm.
Okay. Um. So 1, 3, 2, 4. We see that uh, the start and the end. Okay, so we see that one of the start is smaller. Um, one of the end is greater than the other start. So like 2 or 3. So we have that. So two is the start and 3 is an end.
Mm-hmm.
No, no, yeah, yeah. So that tells us that it's an overlap.
Okay. But how do I know this doesn't represent well this okay, so let me see if I can let me actually tell you the answer because it seems like you're struggling with it. This 1 and 2 here. One represent when an index has 1, right? It means the start of an
Mm-hmm,
interval. When index 2 is
mm-hmm,
the start of an interval. Now we have 2.
mm-hmm,
We have 2 intervals that we have opened up at this point, right?
mm-hmm.
Do you see?
Yeah.
So, what's this relationship? The relationship is that we can just go along and then add 1.
Uh-huh.
So, iterate through and add the ones. And then if any of the what if the sum is greater than 1, then we know there is an overlap.
Mm-hmm.
Did you start to see why?
Yeah. But like, why are we adding 1 to the 2 again? Because like when we hit 2, then we know that it covers. We know that it covers 2 to 4 does cover 2. So we increment that by 1. Is that
No, because
are we?
again, let me go back because I lost you. So let me start off let me repeat the example. So you have array at interval 1 comma 3, right?
Mm-hmm,
So that means that we're going to open the interval at 1 and
mm-hmm.
we're going to close the interval at 3.
Yeah.
2 is equal to nothing because we only want to mark the starts and the end, right?
Mm-hmm.
Now, if I go back and do 2 and 4, that means that 2 and 4, that means that I'm going to open an interval at 2 and I'm going to close the interval
Mm-hmm.
at 4.
Mm-hmm.
Now,
Yeah.
if I go along this, then I see, hey, I've opened up an interval, right? Because I see a 1.
Mm-hmm.
Now I go to number 2. Hey, I've opened up another interval. Well, we never closed out this first interval, right?
Mm-hmm.
So, because if we close out that interval, then the sum would be 0, right?
Yeah.
So if I go, let's say, let me backtrack a little bit. So if I went back here and
Uh-huh.
did the exact same thing and I iterated through it, then I can see that hey,
Uh-huh.
I'm opening up at 1. I go to my running total is
Uh-huh.
still 1. Running total is still 1. I can add 0 to it, but it's still gonna be 1. And then 3, running total so far is 1. Then plus -1 is gonna be 0 again.
Uh-huh.
But in the case of the overlapping intervals, I see that if I did the exact same thing, I would have a sum of 2. And that
Mm-hmm.
means that, hey, I've seen 2 open intervals so far, and none of them have, and the first one didn't close.
Uh-huh.
So,
Oh, okay.
mm-hmm. So you start to see
Yeah.
how I built that idea up?
Yeah, yeah. So yeah, that makes a lot of sense now. Mm-hmm.
And so I know it's like difficult for you to see it because you have never really thought of something like this before, but hopefully you were able to actually understand. And the way I was able to really derive this was really just by drawing things out and then just like kind of noticing a pattern.
Mm-hmm.
And so what I would say definitely for you is like you saw how the idea progressed, right?
Yeah.
I think for you, what you need to do is try to not just understand the optimal solution, but try to understand what it takes to go from the naive to optimal solution as well.
Hmm.
And then something like this needs to be will come naturally, I think.
Hmm.
And so you can begin to see how this is order n, right?
Yeah.
Okay. Like I don't want you to say like yeah, just like just like yeah, but I mean like, do you understand how this is order n? Like actually understand? Is there any point of confusion?
Yeah, I think it's order n because we're basically we're just incrementing every time when it's either close or when it's either the start or the end, then that is what we're doing at each interval.
Yeah,
So
essentially for the entire. Let me see if let me simplify what you just said. So, if I have my queue here, right? More should I say my array of intervals, right?
hmm.
So for every single interval I do two operations, two ops per interval, which is just marking the start and end of in the array, right? Which is just my plus one minus ones, plus one
Hmm.
minus one, right? So this is just going to be an order n operation. Now,
Yeah.
I'm going to iterate through that array again, through array, and then keep, and then get the value at that array index,
Hmm.
and then it's check my sum. Add that to my running total and check my sum. So
Hmm.
this is just an order max element, which is equal to essentially it's a finite amount, which is still on the order of order n, give or take a couple hundred. But it doesn't. But this doesn't scale with n. Rather, it just scales with the number. With if I go back up here, with and copy this. This this max element, I should say, scales with this number here.
Yeah, that makes sense. So if we have like 1,000, then like the step of iterating through the array and then um changing the value would depends on the maximum value that we have in the array. Okay.
Yeah, but it's still like a It doesn't scale with n. It just scales by a different dimension.
Yep.
So hopefully that clears things up. And so,
Yep. Perfect.
action plan. What I want to see from you is, I want you to be able to spend more time on the problem, not just understand the solution, understand what it takes to go from your current naive solution to the optimal solution. What insights do you need? What keys do you need? Like, oh, if I saw this, I would know to do this, and if I know to do this, then I know how to get there.
Hmm.
So just taking that extra step to really make sure that you understand how to go from naive to optimal, not just get the optimal off the bat.
Yeah. Um. So actually, like for now, I haven't I haven't really set up enough money to buy the course, the rocking the interview course yet.
Mm-hmm.
Um, but I've seen like I know my friend has it, and she said like um they do go through the um they do point out the optimal code and for the solution,
Uh-huh.
like she mentioned the consistency of the quality of the solution, but I'm just wondering like do they also go through the process of getting from the naive solution to the optimal solution with that course, or is just something that
Some problems they do. I know they do that for the dynamic programming course. They go through the monotonization. They go through the recursive version. They in the monotonization, then they go to the dynamic programming version of the problem. They also do that for some problems as well. I think EPI does a better job of this though.
okay.
But personally, where you're at, I would just try it on every single problem that you are currently running into. Um, yeah, but grokking is just patterns, but um, you should also try to figure out what insights you need to actually be able to solve a problem, and that's irrespective of patterns. Like
Hmm.
this really didn't match a pattern at all, right? But it still required you to actually mechanically understand what it takes to go from a naive solution to an optimal one.
Hmm. Sorry, I'm just taking some note here.
That's fine. I'm gonna send you this recording anyway, so just yeah, do your thing.
Oh yeah. Yep. Cool. Um, so yeah. Um, yeah, I think that definitely makes sense because right now I'm only looking at the solution, understand the steps, but I didn't really pay attention to how people arrived at that particular solution.
Mm-hmm.
So I guess that yeah, like you said, like that is what really keeping me from yeah making my thought process a little bit more structure in the interviews. So it's yeah, it's something that I will definitely try to work on.
Mm-hmm. Yeah, like it's gonna take you like twice as long or three times as long for sure, but
Uh-huh.
it's almost always worth it because you're gonna be able to progress further in these problems than you would if you didn't.
But then I guess it goes back to the question of efficiency again.
Mm-hmm.
Um, like I'm about like I guess like right now is July and the recruiting season like when the interviews happen will be somewhere in like late August and September.
Mm-hmm.
So I'm just
I think
thinking
it's late
like
September actually.
oh, okay. So like with like I guess about like more than 2 months that I have left, like when I attempt a problem, should I like do you have like an eyeball at like a ballpark estimate of how much time I should spend before like jumping to the solution, or is it more the matter of like
When you can actually say that you have tried everything you possibly could, then you can
mhm,
look at the solution. But when you look at that solution in that case, I want you to be able to find a way of going from your current naive solution to that optimal solution and figure out, okay, what insights did you need? What was the thing that you needed to look for? Did you need to go back up and assume different things? Did you have to challenge your own assumptions? And the reason why I don't like leak code is because they are very inconsistent with their solutions. Um, and so it's much harder to get a dial in on that. But it's still a good exercise to do, and it's still very doable.
yeah, 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 I can definitely attest that because like sometimes you see all the most upvoted solutions are they seem to be actually the worst ones because like people just don't really pay attention to the best
And
practices
yeah,
and
and they're not even that readable as well. They're like written by competitive programmers who are like completely fucking smart, but you're not gonna learn anything from that because the variables mean names mean nothing. I mean,
yeah,
you can
sure.
try and parse it for sure, but it's a huge waste of your time, and you're better off just like. I still think this is something that is probably worth like investing in a book. And if I actually had to recommend one book, I'd still recommend EPI.
Hmm. So yeah, but I saw I think I saw yeah I saw on your guide like API is a little bit more advanced.
Mm-hmm.
So should I use that right now as a complement to my studying, or is there like a better way to start? Because I'm not sure if I'm really at the level of doing API.
No, it's
Uh,
fine. Like everyone, no, like EPI. Like once I got done with rocking and everything else, EPI made me feel like a noob all over again.
mhm. Okay,
Oops, wait, hang on. I disconnected my headphones.
sure.
Sorry. Yeah. So what I was saying is that EPI made me feel like a noob all over again, and that's completely normal. Like I
Yeah.
thought I could throw patterns at it and try it out, and then it's like, yeah, it got me far in some of them, but like what it really trains is the insight and understanding how to break down these patterns, and I still think it is by far the best one because again, you're not going to be able to necessarily make a whole lot of progress just memorizing patterns. I would say for you, if you are struggling with dynamic programming trees, get that out of the way first. Do some lead code problems that are specifically geared towards that, and once you feel like you have a very good handle on it, once you can write out like a depth first search, breadth first search, in a very how to say off the top of your head, then go straight to then go into it. I put out a video on how to study, and again, I know you haven't done you don't have grokking with you, so I think the next best thing for you is really just to try and do one data structure at a time. Try the problems grouped by particular data structures, and then jump into EPI. Like 2 months is
Okay.
2.5 months is a plenty of time, man. I did mine in
Mhm.
like I did my studying from nothing to what's it called to interviews in like 6 weeks.
Okay. Yeah. Um, but I do feel like it does irritate it does take me quite a little bit of time to digest things. So
Sure.
yeah, I'm just trying to be, I guess, like, because I saw people saying like, okay, you should only spend like 20 minutes on the problems, and if it doesn't work, then go straight to kind of save time. So I'm just kind of like, at this point, I'm just sometimes I'm afraid of like being too inefficient with my study if I try too many approaches.
No, you should
Um,
try every single fucking approach and then understand why it didn't
oh
work.
yeah,
Like I don't
yeah,
understand why people say, "Oh, give up after 20 minutes." What the fuck does that teach you?
yeah, that makes sense.
But if you try like every single wrong approach, then you know not to do it the next time, right? Or and then if
Hmm.
you actually try to figure out, okay, what does it take to go from the naive solution to the optimal solution, then you understand how to do some of the problems in the future. Or at the very least, you practice your ability to break down problems.
Hmm.
So it's about spending that little bit more time and just like, you know what, just you've tried everything. Fine, I'm okay with you looking at the solution. But if you look at the solution, then I better see next time I give you the exact same problem, you know how to go from the naive solution to the optimal one instead of just memorizing the optimal solution.
Yeah, but like how to kind of like try things out in a structured way, because like you said, like, because I guess you can saw in the interview, like I was just kind of like throwing random ideas that didn't go anywhere.
Mm-hmm.
um I guess, is there like a good way of like trying things in a structural manner rather than doing random things
Yeah, like
like
I
that?
covered this in my video. Look for preconditions. Look for things in the problem that allow you to really use these patterns. And you saw like how the moment I generated examples of like if I'm going back up here, where I just generated the examples of all the possible ways the intervals could overlap. Then I just came up with, oh yeah, you don't need to check the maxes or mins that like you were doing, right?
Hmm. Hmm.
Same thing over here. I just generated it. I just drew it out, and you can see, oh, what if I tried representing this as indices?
Hmm.
And then from there I just built upon that idea and just drove it.
Hmm.
So it's about just like just start from drawing examples, see if you notice any patterns, and then
Hmm.
drive that idea as far as you can.
Hmm.
And then
Yep.
again, like sometimes it doesn't go because you can't figure it out. Fine, again, go back to the solution, and then figure out what it takes to go to get to the solution from your naive one.
Hmm.
And usually
Yeah.
it almost always begins with drawing these examples, and this is something that I don't see anyone like a lot of people do. Like you should just be able to draw the example and identify all your cases. In fact, like watch the how I did the where I did the binary tree problem, where I did like the sum to path,
Hmm.
and then just see how I was
Hmm.
thinking about it.
Okay. Yep. I'll take a look into that. Put that down here. Cool. Um, yeah, just a little bit on how these interviews are carried out.
Mm-hmm.
Like, would you expect a candidate to solve this problem within like 30, like, if it's like for a good candidate to solve it within like 30-35 minutes, or what would be the cutoff?
Something like this, I would expect with Candid within 35 minutes. Actually, 30 minutes might be
Okay.
might be pushing it. So because it takes time to understand the problem, especially if they haven't seen it before. So I think, yeah, getting up to the sorted time, like 15 minutes is fine. And then I would expect give them another 10 minutes to figure out this interval one, 10, 15 minutes to figure it out.
Mhm.
And then by 30 minutes, they should already understand what to do. And then it should only take them like 5, 7 minutes to write the code. So 35 minutes is probably what I would aim for. And I know usually these intervals we give you like an hour to 50 minutes. So this would almost take up most of your time. Um, so
Okay. Yeah. Um,
honestly, though,
and,
if you're a freaking baller and you understand how to do these problems and you actually understand like what to look for, you can get this in 25.
and like, so this kind of falls into, I guess, the medium level of difficulty, right?
Yeah,
Uh,
it's a medium level problem. I only give medium level problems only because a lot of them you can be built off of. In fact, like there was this one problem that I'm shooting the video for that I'll upload next is how to implement implement a solution to a problem where breadth first search was the most optimal one. Instead, I used depth first search just as a challenge.
mhm.
I mean, I'll upload that, but I'll say that it was pretty crazy, like just trying to figure it out. And there's like so many things that can be pulled away from it, like oh, don't try to keep a global list while you're doing recursion because it just handling that is kind of bad. and messy, and then trying to keep complicated indices as well. It's like all these small little things that contribute to inefficiencies and problems. And
Hmm.
just being able to identify that when you go to write your own code. Like if your code is breaking, but it reflects your idea, then and then you have to bust out the system out print ln or whatever it's logging. Then you know you're doing something wrong.
Hmm.
So it's like being able to identify why do I need to spend so much time here? Can I avoid that?
Hmm.
So
And like, so I guess for those kind of like hard problems, then would it be like 45 minutes to get to some sort of like suboptimal solution, or what is the time cutoff look like?
so realistically, I think most people expect you to take the entire time, so like 35, 40 minutes. But they usually pair it with a hard problem. I mean, a easy and hard problem, in order to fill up the time. But as I say in my video, I would benchmark myself to try to aim for 30 minutes for a hard problem, and then 25 minutes for a medium problem.
Hmm.
Just because, like, if you're doing it on pencil and paper, you don't need to justify the problem to someone else, um, and so that should save you a lot of time.
Yeah. Okay, that makes sense. Um, yep. And just for like, I guess for like my process of like, um so I my process of working for a problem, let's say like, in the case that I got like, I know the idea of how to approach a problem, then
Mm-hmm.
after working through the examples, then the next thing I would do is to test it against an example,
Mm-hmm.
and then write out the code and shoot. And after I write my code down, are like, would the interviewer expect me to kind of like go through my code again with a concrete example, because that seems to take a little bit of time, or is it still like a required step?
It's a required step just to make sure that it reflects the idea. But I would
Mhm.
also say to make your idea bulletproof is to come up with these all possible cases. So that so going back to what I was saying before about ABC, like start
Mhm.
start end, start B start. These are all the possible cases, and then I would generate examples based on these. Otherwise, you're just generating random examples like the one you did up here. That is not any more meaningful than the
Mhm.
ones. These two, there's no difference between these two in my eyes. It's not meaningful at all.
Mhm.
So just being able to cover all the possible cases in a generic version, and then generate examples for each of those generic versions, and that just proves your idea to the interviewer, and it shows like you actually thought it out. You might miss a case, sure, fine, it happens, but
Mhm.
you need to be, but you should at least spend like all that time on one problem, on one mistake, instead of trying to spend like twice as much, or maybe I should say 1.5 amount of times on three problems or three mistakes that you make.
Mhm.
Like it's just that small investment of time in making your idea that much more bulletproof that'll save you a lot of headache debugging your code.
Yeah. So yep, just we have very good, I guess it does go down to having very good examples that we can look back and test our code against.
Yeah, pretty much.
Mhm. Awesome. Um, so I guess just one final question about these whole interview things. I know that we they usually have like a 5 minute behavioral portion at the beginning. So I guess within those short 5 minutes, what are the expectations of the interviewer, and what are some like some general tips of what to do within those 5 minutes of introduction?
It's really just seeing that are you actually a programmer, really, especially for someone at your level. I would say it's like, are you capable of communicating as a normal functioning human being? Because most of
Okay.
the time, those 5 minutes are not enough to really know someone or really understand them. The interviewer is just really there to see your programming ability most of the time, unless you're going specifically for the behavioral interview. Um,
Mhm.
and then that's like a full 40 minutes. That's a whole different topic. But the 5 minute introduction is just like, okay, just give me a brief idea of your responsibilities, and so I can kind of have a general idea of where you are as a software developer. It's really just a general sense.
Yep, that makes sense. Um, so I guess just to make sure that we have um, like a quick short introduction, and and maybe don't fret about it too much, but
No,
more like for the behavioral interviews,
save
if
that for the
we
behavioral interview. Yeah.
oh yeah, awesome. Um, So I guess that's about all the questions that I have for now. Thank you so much for spending almost like 2 hours with me today. Yep, I really appreciate it. I learned a lot for a session.
Good.
Yep.
Hope that you improve, and then if you need if you get an interview down the road, just holler at me.
Oh yeah, thank you so much. Yep. Have a good night.
All right, you too. Take care.